Hey, so we're going to talk a little bit more about angles and how they're formed in circles. And here I have three different circles and three different types of lines, and they're all going to sort of interact the same way. And here's a formula I have. So I have angles, and you can see they have a little blue arc there in all of them. I'll highlight that. There's an angle, there's an angle, there's an angle. So the measure of that angle is related to the arcs that are formed by these segments. And let me first point out that I have two different types of segments here. I have a tangent segment there and a tangent segment there as well. These are types of segments or lines that will touch a circle in one point, so right there, and then never touch it again. So I have another tangent segment right there in this picture. And then there's also what's called a secant segment. And that's a segment or a line that goes through the circle. So you can see this, if I continued this, it would go right through the circle. And then both of these are secant segments as well. So let's talk about how these segments interact with the circles and create these angles. So I have these three angles created. This one by two tangent segments, this one by a tangent and a secant segment, and then this one by two secant segments. And in all of them I have some arcs formed. So I have a small arc created in each of them between the two segments. And then I also have a big arc created in each of them. And you can see that the arc is between the two segments. So the formula for the angle relationship is that if I take the big arc, so the one I highlighted in green, and I subtract the purple arc, the small one, and divide it by 2, it will tell you how big the angle is. And I like to shorten that up just using b minus s on top. So if you're writing the formula every time like you should, you can just use b and s instead of big arc, small arc. So if I'm going to measure the green arc and the purple arc, the big and the small one, I can plug them in here and find the angle. So let's try one. Here I have the angle. I've labeled it question mark, so we're going to find out how big question mark is. I have a small arc of 57 and a big arc of 175. And that's two secant segments making this. They both go through the circle. So I start with my formula and I plug in what I know. And I simplify to eventually figure out that this angle formed outside of the circle is 59 degrees. So here I have two tangent segments. These two segments are just touching the circle at J and L, and then they'll never touch the circle again. But they do meet and they form this angle out here, question mark. So we're going to use our formula. It's not as obvious here what the big arc is. We know the small arc is 110. There's only two arcs in this circle created by these two tangent segments. The whole circle is 360 degrees, and the small arc is 110, so if we subtract 369, 110, we can find out that the big arc is 250. So we'll plug big minus small in, simplify, and we get that this angle is 70 degrees. So in this example, again, I had to figure out what the big arc was because I didn't know it directly, but it's 360 the whole circle minus the arc that we know, and that gave us the B, or the big arc here, is 250. So in this example, I have a tangent segment here, and I have a secant segment here. I want you to pause right now and find out how big the angle is. Find question mark. So again, we're starting with the formula. The angle is equal to the big arc minus the small arc. My big arc between the secant and the tangent is 129. My small arc is 61. Whoops. Sorry about that, I hit the home button. I'm plugging in. I find that the value of question mark, the angle there, angle L, is 34 degrees. So we have one more situation that's kind of similar. This formula looks very similar to the inscribed angle formula. It also looks similar to the formula I just gave you, b minus s over 2, except we only have one arc to deal with. So I have a tangent line here. This line is touching the circle at point L and then never again. And I have also a secant here, and when they intersect, they create this angle at L. And also we create this arc between the tangent and the secant. And the relationship is that this angle that I did in yellow is equal to this arc divided by 2. So again, it looks very similar to the couple formulas we've had already, but it's a different picture, and this relationship exists. So let's give it a shot here. I have this tangent line, and I have a secant line, and I'm going to look to see how big this angle is if I know that this arc is 130. So I start with the formula. I plug in 130 for the arc, and I find out that that angle is 65 degrees. So on the flip side, if I know the angle, I can just double it to find the arc. So we'll do another one. This time I know the angle. So when I plug in, I'm looking for the arc. That's question mark. So I multiply both sides by 2, and I find out that the arc is 152 degrees. And just as a reminder, kind of a heads up, it's the arc we're talking about is between the tangent and the secant, and it's created by this angle. So it's this arc over here, not the big guy over here. So pause here, please pause and find the measure of the angle there, SRQ, or the value of question mark. So again, you should always start with the formula. If you write the formula down every time, it's going to be cemented in your memory. We'll plug in question mark for the angle and 146 for the arc. And then it's just a simple division here to get that the angle there, question mark, is 73 degrees. So there's two you-dos here. Try these two problems. I have one here with a tangent segment and a secant segment, and then I have one with a tangent line and a secant line here. The two different scenarios we talked about in this lesson. Find question mark, submit your answers online with the Google form, and bring any questions you have to class.